We have a lot of people here. We've got over 2,200 folks still, which is awesome. But we've got a wide range of skills, and it can be kind of hard to create labs that can be challenging and appealing to a wide range of skills. So here's what we're going to do. Each of these labs is going to be a problem. So it's going to be something like, hey, here's a data set, and how would I find the longest connections that are taking place, or something along those lines. And we're going to ease into the answers, meaning that I'm going to give you the problem and that's it. Now, if you've been using, Linux forever, T-Shark forever, Zeek forever, you feel like, I'm a guru, I could teach this class type of thing, use that first slide and just run with it and go from there. If, however, you look at that and you say, okay, I kind of understand this and it makes sense and I know we talked about it, but I'm not really sure how I should go about solving this problem, go to the hints page. And on the hints page, I'm going to talk you through the process of solving the problem. Not necessarily, hey, here's exactly what you need to do, but I'm trying to, north, south, east, or west, I'm trying to point you in the right compass direction to figure out how to go through and solve that problem. If that's enough for you, jump on it, go from there. If you go through the hints and you feel like, okay, yeah, it makes a little bit more sense for me, but wow, I'm new at this and I still don't know what to do, the next slide after that is all of the commands to run in the order to run them. Copy, paste those into your terminal session to see what the results look like when they come back. The other reason I wanted to give you that is if you're looking at something and you're like, whoa, how does this work? In other words, a raw Zeek con log, how did we go from that to this cleaner output that I'm looking on the screen? Up arrow, delete a bunch of the commands and just run the first one. And now pull back that original command and only look at what you get when the first two commands come out. And the first three commands come out after that. So allow you to kind of walk through it. And then the next one after that is the exact commands and the solutions. So I have all the solutions built into this deck for you as well. So what I'm going to do is I'm going to give you the problem. I'm going to give everybody a couple of minutes to kind of work through that rather than giving the entire lab time and then just going through the answer. I'm going to wait a little bit and then I'll cover the hints with you. And then we'll wait a little bit. I'll talk about the commands and then I'll give it a little bit more time and then we'll actually go through and talk through the results. So with that in mind, the first thing I want you to do is I want you to identify long connections. So all of the labs are going to be done in this home T-Hunt lab 1 directory. So just CD into that directory and we're going to be working out of there. In there, you're going to find a PCAP file and a bunch of Zeek logs. All of these Zeek logs were created off of that PCAP file. So it's the same data in both. It's just broken up and presented differently. And I want you to use either the PCAP file or the Zeek log files, whichever you think is most appropriate, to identify the top longest connections that have taken place between a private IP address of someone on our internal network generated out to a legal IP address, somebody out on the internet. Bonus question is, okay, now I want you to look at cumulative talk time. So not just the longest unique sessions, but as we talked about, over whatever period of time is in that file, and I'll give away one hint now, you kind of need to know how long that capture file ran for, how much Zeek data you have to work with, what's that time interval, what's the longest cumulative time between any two IPs. So go in, give that a shot, and I'm going to go in and kind of help with the chat questions too, and I'll give folks, let's say, about 5 minutes, and then I'll go through and I'll kind of move it forward from there. So yeah, I see a question. So just dive right in. Absolutely. Just dive right in. So this slide, take a look at it. Can you figure out how to solve the problem? If you can, hey, there's your data. Go have a field day with it. If you're looking at this saying, I have no idea. I gave you the PDF for the files for the slide deck already. You on your screen, flip down to what the next slide says. That's going to be your hints. Read those and see if that can get you going. So I see somebody posting into the chat that they can't type a pipe character. So two possibilities. One is you can't do it in the terminal for some reason. The other is that it may be a keyboard mapping issue. Try this. After the hints is in that, so that PDF I sent you, 2 slides after the one I have up on the screen right now is the exact commands. Copy a pipe character. Copy that to your clipboard. Now go back in, start typing, paste it into your session. You can kind of get around the problem that way. And I just saw, go by if you have a non-US keyboard, here's the key set command, and it scrolled off the top of my screen for me, but someone was kind enough to flag that. Thank you, thank you. Where's the deck PDF? It is on the same site where you downloaded the VMs from. So go to that site, and just above it now is a new downloadable file, which is the PDF, which is a copy of all of these slides. After this presentation, we'll make the AV available on that same site as well. So I see a lot of people asking, where do I get the PDF from? This link right here. So this is the same link you used to download the VMs. Go to this page. If you get prompted for a password, this is the password to use. And then scroll down just a little bit, and you'll see a downloadable PDF version of all the slides. You can grab it from there.
And that link and password is still posted on the top of the chat screen.
Oh, thank you, Shelby. You're right. So yeah, if you look at the top of your chat screen, you'll see this information is already there. And Keith, I'm not sure if you're seeing this in the chat. It looks like some folks are having trouble trying to get to that PDF file.
Yes, actually, I just saw that, so I'm looking into it.
So that's my bad. I should have put that on S3, and instead of giving you the PDF, give you the link to it. So for everybody, this is not Keith's fault. This is mine. Everybody come at me with the torches and pitchforks.
No, it's not your fault either. Earlier, we had a bit of a network snafu. I'm not sure if it's Cloudflare or what's going on, but right now, in fact, the page won't even load for me. So just a moment, I'm checking.
Okay, so for the folks that are having trouble downloading the PDF because we've DOSed our own website, I threw into the chat, and I will do it again. Here's a link. So this is an S3 link. Use that link to pull down the PDF instead. That'll pull it down off of S3. That way you don't have to worry about trying to get it off of our website. So I see a couple of folks saying the site's down. Let's see. I seem to be able to get to it right now.
Yes, actually, the server did go down for almost 2 minutes. It's back up now.
Okay. So again, this is not... We expected 200 to 300 people to show up for this. We did not expect... God, it was just under 6,000 people when we closed the door on it. So I apologize for the technical difficulties. We were trying to scale things up as quickly as we could. You know, one of the things we kind of missed is this. Keith, that link to S3, maybe if we modify the page when we get a chance, probably not now while people are trying to use it, but if we change the link to point over to S3 instead, that makes Amazon deal with the traffic versus us. That might make it easier.
Yeah, I'll go ahead and switch that now, but I'll leave both of them up. That way we have options.
Cool. And I see somebody saying, thank you for the lecture. Oh, absolutely. Thank you, folks, for giving up time on your weekend to listen to me. That's, you know, we talk about it being like, you know, a free webcast. It's not. You know, you're spending the collateral of your time to come and listen to us. That has value. So, you know, folks, it goes both ways. I appreciate everybody showing up for this. Okay, let me move this forward a little bit. So I wanted to go in and find long connections. So the idea is in that lab one directory, again, you get a PCAP file, you get a bunch of Zeek files. So there's your data to work with. We want to identify what are the longest session times and which IP pairs are in communication with each other the longest. Those are the things to go and look for. Now, long connections is a relative term, meaning that I may go in there and see, oh, yeah, I got a bunch of 1 hour connections. That's not too bad. Well, if I look at the PCAP file and I see that I only have a 1 hour packet capture, well, that means it was there the whole time. You're right, that's not that long, but that doesn't necessarily mean any of those are safe. So one of the first things I like to do is get a sanity check on how long was that capture file run for in order to generate that traffic. And once I know that, now I know what my maximum is. So if I look at it and I see, okay, it's a 12-hour packet capture, now anything that's been running for 12 hours is interesting. If it's 24-hour packet capture, anything running for 24 hours is interesting. Now, PCAPs don't store connection duration, meaning that to try and get this data out of the PCAP itself, it's going to be really hard. Remember what we said. We need to see when the SYN packet went out, when the FIN packet went out, and that's my duration. There's no real easy way to do that using like T-Shark or a TCP dump. So I might want to stick with the Zeek data to figure that out. Zeek's con.log file, I showed that earlier and mentioned one of the fields is duration. That's something I can go in and target in on. So let me give folks a little bit more time to go through this, and then I'll go through and kind of cover it from here. And Jacob's saying he likes it when the banter keeps going because then he knows he hasn't actually kind of dropped off from this thing. I apologize for that. Yeah, I don't want to talk too much to distract people while they're trying to do their labs. I can do little hand dances. Maybe that'll help. When you see, I'll tell you what, I will keep moving around. So if you see me moving on camera, you know you haven't locked up. You know everything's still running fine, but then way I'm not talking and disrupting people while they're trying to do the lab. So your question, where are the Zeek files? Everything is under the lab one directory. So home/thunt/lab1, all the files you need to do all these labs are located in there. And someone's saying they like the sword behind me. Yes. So that is a claymore. That's a very cool sword. I had one similar to that kept that kept guys away from my sister until she reached 18 years of age. Let's see, statute of limitations has run out, so I can talk about this. So I was a bit of an overprotective big brother and had a little bit of a reputation in the town I was in as like someone to be afraid of. So my younger sister found it hard to actually find dates. There was an episode where some guy was in the house that shouldn't have been, got chased out of the house with me waving a claymore sword over my head. You know, they were banned from the whole north side of town, and I guess they were scared to ever go north of the center of town after that because they might run into me and, hey, I have a sword. But funny story along those lines. So I had, moved out of my parents, staying in an apartment, and I'm sleeping one night, and I wake up and my face is in pain. And as I wake up and my face is in pain and I'm half asleep and I'm trying to figure out what's going on, I see the back of my sister heading out of my apartment. I'm like, what just happened? So I try to go running after her. And by the time I get up and get to the door, she's already in her car and she's driving away. And I'm talking to one of her friends the next day. And I said, yeah, weirdest thing, my sister, I think she hit me in the middle of the night while I was sleeping. And her friends just starts laughing her butt off and told me they were at a party the night before. My sister met some cute guy. They were talking, excuse me, they were talking, getting along very well until the guy said to her, hey, so what's your last name? And she said, oh, it's Brenton. And he looked a little shocked. And so said, oh, you mean as in Chris Brenton? And she said, yeah, that's my older brother. and she turned the other way to answer a question for her friend, turned back, and the guy was gone. So apparently that ticked her off enough to go decide she needed to hit me at that exact moment. So like I said, her dating life was tough and it was my fault. But what makes it all worthwhile is she had a friend with an older brother that was like the whole front line for the football team, and decided that Brian was big enough to menace me and get me to not chase him with a sword. So she was going to have Brian over and pretend that Brian was her boyfriend, because this would be somebody I could not pick on and maybe I'd back off after that. So she brought Brian over for Thanksgiving dinner and, came right up to me and said, "This is my boyfriend. Like, I dare you." And I looked at him and said, "Brian, it's nice to meet you. You seem like a nice young man. But, just so we're on the same page, you hurt my sister, I'll take you out at the knees. I don't care how big you are." And I just turned around and walked away. Well, her and Brian started talking. Turned out they had a lot in common. They actually started dating. They got married. They're still married after 20 years. They have 2 kids. And you can imagine how much it annoys my sister that I bring up to her that the only guy I let through without chasing with my sword is the guy she's still married to this day. So yeah, I'm kind of a sword guy. And on the end of that story, let's move this along a little bit further. So here are the commands I gave you. So like I said, the first thing you want to do is sanity check that file. You want to get an idea of how long did the capture take place for. This cap infos file, binary will do that. So you can feed into it a capture file and you can say, tell me when this starts and when this ends. When does this capture start? When does this capture end? And it'll print that out for you. And now you can see, okay, what's the longest period of time I can expect to see from any connections inside of this file? This command here, notice we're going in, we're looking for duration, and then we're sorting it. So this is just going to reverse sort it. So it's going to sort it highest to low, and it's going to show me what are my longest connections. Down here, we're doing exactly the same thing, but we're dumping it through data mash to add up any connections between IP addresses so we get a cumulative effect. Got a couple other commands in here too. This grep-v and this grep-v. This one is saying, hey, if it's a blank line, ignore it. This is saying if the line has a dash in it, ignore it. What Zeek does if I try to connect to an IP address and it rejects my connection because the port's closed, the IP address is offline or whatever, there's no duration to that. So rather than list a time, it just lists it with a dash. Well, data mash wants to add numbers together. A dash is not a number. So when it sees that, it pukes on it. So we need to filter that stuff out in order to have data mash go through and add things. So if you need to figure out what to do next, copy paste these out of that PDF file. Where to find the PDF file is stuck up at the top of the chat. Or I shared that S3 link. That's in there as well. Copy paste these out, run through it, give me a couple minutes, and then we'll go through and we'll cover this one as a final. So I saw somebody ask a question, am I seeing this right? The first packet is after the last packet? No. There should be there's a 24-hour period of time between the two, but it's like 3 seconds shy of exactly 24 hours. So if you look at only the times, it could look like it finished before it started. But if you look at the dates, the start was the day before it actually finished. So the question was, can I provide some context on what the last 2 commands do here? Yeah, I'm going to get into this more as we get into the actual answers, but I'll kind of talk through this now, just folks, just that way I can take a little bit more time with it. So we're listing out the contents of conlog. Brocut needs to take input from somewhere. So we're just listing out all the con.log files. There's only one in this directory, but normally with Zeek, it'll break out conlogs into 1-hour intervals. So the command I show here will make sure that you grab all the conlogs, not just one of them. And then I'm using brocut to say print out the source IP and the destination IP and the duration. So if you want to, so one way to kind of learn what this stuff does is run cat space con dot star log, and then that's it. And take a look at what the output looks like. Then add in this second part with brocut. And now you see, okay, before it was a ton of stuff on the screen and it was really hard to read. And now I've got 3 clean columns, a source IP, a destination IP, and a timer telling me how long that connection took place for. Now add in this command and look and see what it does. Well, what this does is this sorts that data based on the dash K3 is based on the third column. So if all I said was sort, it'd try and sort it based on the source IP because that's the first bit of information it sees. And I'm telling it, no, skip over this value and skip over this value, go to the third value, which is the duration, sort it based on that. N means you do it as a number, not as just like a raw ASCII value. So if I don't use dash N, 1 could sometimes show up before 2. Well, 11 is bigger than 2, but it's just the way it goes through and sorts it. So if I tell it it's numeric, it will do it in an actual numeric sort. And R says do it in reverse, meaning I want you to print to the screen the biggest number first, the smallest number last, not the other way around, which would be the new automatic. This next command is exactly the same thing. The difference is I'm going in and I'm saying, pull out any blank lines, pull out any lines where there's a dash because there was no duration to the connection because someone tried to start the connection and it died right off of that initial connection attempt. And data mash is saying anytime the source IP and destination IP address are the same, add together all of the durations. So now instead of seeing maybe 5 entries between 2 IP pairs where they had 5 different conversations, I'll see one entry, and that one entry will be the cumulative time or all 5 of those durations added up together. Sort it out, print it to the screen. Yeah, for the folks, when can I get the slides? You can download them now. You can pull them down at any time. Yep, you could use column names here too if you want to. It takes a little bit more work to make sure you get column names and not have them end up getting sorted and moved around. I'm lazy, so I didn't bother keeping the column names in here as part of this output. It also makes it a little bit harder to read. I'm trying to keep this simple for the folks that maybe this is the first time they've done scary, hey, run this command, pipe it through that command, pipe it through that command, pipe it through that command type of things. RITA is about to become your best friend. Yeah, it is. So I'll admit there's a little bit of a method to my madness here. A lot of these hands-on labs we're doing, RITA does this for you. But I think, like I said, I think it's important that you understand what needs to happen in the background for this stuff to work and how to do it manually when you want to validate what a tool is reporting back to you. But yeah, when we get to RITA, you'll see this RITA just does it for you. You don't have to type all this stuff. So RITA is a whole lot easier to scale than trying to do this manually on the command line. So let's kind of talk about the answers. So like I said, I need to know with the PCAP file, it'd be a pain to do it there. It's a whole lot easier with Zeek. So let's just do this in Zeek. I need to extract out source, destination, IP address, and how long did the communication need to take place. I also need to be able to go in and kind of add that stuff up. So CAP Infos is a great tool for going in and identifying how long was that capture done for. Now, someone had commented, hey, it looks like the last packet was seen before the first packet. And if you look at just the times, they're right. But here's my date stamp. And notice this took place on the 30th. This took place on the 31st. So I'm, 2 seconds more than a full day I've got worth of data here type of thing. So this is pretty, let's call it even, exactly 24 hours worth of information. Now, CAP Infos has some limitations to it. If you have jumbo frames in there, it pukes on those. If you have really large capture files, it pukes on those. So The plan B down the bottom is this is what you do when if you try cap infos and cap infos comes back and gives you some sort of an error, you can run it through TCP dump. So this first command here is telling TCP dump, I want you to make that screen go away. Thank you. It's telling TCP dump -TTTT changes the time format to be very similar to this. It changes it to be very similar to this time display format that's being shown here. This awk command at the end is just saying grab the first line and print it, grab the second line and print it. So I'll see the first packet that's in the capture file, and then I'll see the last packet in the capture file. So again, I would rather use cap infos, but for those times that cap infos won't scale, go in and use TCP dump. Now, here I'm going through, and I already explained the command that I ran here, so we'll kind of skip that. But notice what I've got. Because I did sort -K3, I sorted on the duration of the connection, -RN, do it in reverse order. The longest time ends up at the top. The shorter times are down at the bottom. So what are my longest connections that took place inside of that PCAP file? What are the long cons that I may need to investigate as possible command and control channel traffic? It's these right up at the top of the list. Now, one of the things you need to kind of work with is, where's your cutoff? In other words, when does the length of the connection become uninteresting? And for me, it really depends on what are you looking for. If all I'm looking for is C2, then I probably want to look for what connections are running like the whole 24 hours. But I can catch some other cool stuff here too. One of the things I tagged in an environment was it was an environment where everybody, when they went and browsed the internet, went through a proxy server. And when they went through the proxy server, that proxy server checked to make sure that you were going to only work appropriate sites. And if you didn't, you got redirected to an HR website and that connection got logged and you were told it was logged. And we had a lot of developers that, hey, I want to go check sites that I'm not supposed to go to, but damn it, I want to be able to go to that anyway. So what they did is they set up a proxy server on their home system. They did a reverse socket SSH connection. So now they'd come in the morning, launch SSH, connect back up to their home system running a proxy server. They would open listening ports on their local system, and they would forward all of their web server traffic through that connection. So now that allowed them to go to any sites that they wanted to and completely circumvent the content checking that was taking place on the corporate network. The way to catch that was they were doing SSH connections that were up and running for about 8 hours a day. So if I want to make sure I can catch C2, I can look for 16 hours or longer, and that's the stuff I pay attention to. If I want to make sure I'm also catching abuses like people tunneling stuff out because they're smart and they think they can get away with it and we will never catch them, I might want to look at time intervals as short as like 5 hours to try and catch folks that are doing that type of thing. So here are our longest connections. And the second part of this was to go through and look at cumulative time, add this stuff together. And this is where data mash was coming from. Now, if you're running this and data mash is giving you an error, the way I kind of go through and troubleshoot this is I will go through and I will look at what was taking place prior to that. In other words, so let's say I run this and the command is choking on something in data mash. Go as far as the grep-v command here and look at the output and kind of scroll through and see, is there anything there that looks interesting? If data mash is barfing on you, and yes, barfing is a technical term, the most likely candidate is that you've got some line where in the duration field is a non-numeric value. So it's seeing a dash, it's seeing a special character, it's seeing something there it's not happy with. So if you go through and you just look, usually you can spot that and say, oh, hey, there's the problem. Okay, now let me tweak my filter to figure out how we get that cleaned out as well. Cool. So we just looked at try to catch long connections. let's go in and see if we can't catch any beacons. So we've got a couple of possibilities for going in and looking at beacons. We can identify this based on timing. We can identify it based on size, meaning that, is the connection going off once per minute? Or are all of the sessions the same size majority of the time? And we talked about how doing it based on timing is hard. So hints on this, you need to be able to clearly identify when the session starts and the amount of payload data that gets transferred, meaning that we need to be able to identify session data, not necessarily packet data. Well, this makes it difficult to kind of pull out of a PCAP again. So Zeek, you might find a whole lot easier to be able to go through because Zeek goes through and does both of these. Let me leave some commands up on the screen for you here. So I'm going to give folks a little bit of time to work through this. Then I'll go through and I'll cover the answers. So I see a note from somebody saying the third command is not working for them. So let me launch my VM and give that a shot. Because I thought I verified all of these, but we all know how that goes sometimes. Okay, so somebody was saying they ran that last command and nothing came back for them. I just copy pasted that last command. You can see what I got back here. I'll talk about what this means in just a second. So it does seem like that last command is working. Maybe it's just missed something in the copy paste.
So while we have people working through the lab, this particular one with most connections, Chris, I'd like to get your opinion on this, but aside from just looking for malware, this is really useful also just to see like the top talkers in an organization, like who's creating the most traffic leaving the environment. And I would say in the past that I've done this, I've found a lot of people streaming like that one gig where they were streaming Bollywood videos on at least 2 to 3 computers for 24 hours a day. It looked like that system was horribly compromised as well.
Wow. Yeah, no, absolutely. Absolutely. Yeah, and actually, while we're into it, let's kind of talk through this one a little bit. So we want to go in and look for beacons. And, Zeek doesn't flag beacons by itself. We need to go in and kind of look at that data and look at it in a way that'll kind of help us figure out, is it a beacon or not? So that first command I had you run, we're catting the con log. So we're just, spew everything that's inside that file. Then we're running it through Brocut. We're saying, I want to look at the source IP and the destination IP, and then I want to sort them so that they're all together. Then I'm saying unique C. So every instance of where the 2 IPs talk to each other multiple times, collapse that down to 1 and count them up. And then sort-RN, this is a numeric value. I want to sort it in reverse order. And then I'm just pumping it through head to say, hey, show me the top entries. So let's start with the top entry here. Is that a beacon? I don't know. I know that my internal system created 108,000 connections to this IP address out on the internet. That's a lot. And now I have to kind of figure out, why did they do that? So I'm going to need to dig in a little bit deeper to figure this out. Is the 64,000 connections one? Maybe, maybe not. So one of the things you got to keep in mind, one of the things you're going to have to do doing it this way is you're going to have to set a threshold. When do I stop trying to decide? What is the smallest number of connections in a day that I want to further investigate to see if there's any beacon-like behavior with it? Where do you put that threshold? John, I don't know what your magic number is. I know definitely like 20,000 or more for me is something that I want to make sure I pay attention to. Once you get down below 20,000, now it becomes a little more iffy.
Yeah, whenever you're talking about just the raw number of connections. Now, this is different than the number of beacons, right? So if you're looking at something like the output of RITA, if you have something that's beaconing out like 24, 50, even 100 to 200 times, you'll see that a lot from things like Google updates and Microsoft updates, things of that nature. Once you start crossing above 500 to 1,000 beacons per day, that's getting a bit more atypical. So as far as like the total number of connections, it really depends on whether or not you're looking at the total number of connections on a system, or you're looking at the total number of beacons, which we will get into a little bit later as well.
Yeah, so to kind of expand on what John was talking about there a little bit. So let's take the third entry just to pick on any one of them. We had 20,000 connections, and John and I are saying maybe it's a beacon, maybe not. Well, why? What's the difference? If these 20,000 connections took place in, let's say, a 10-minute period of time, well, that was just something really busy that took place. That's not a beacon. That's a burst of activity that's different. If, however, those 20,000 connections are all interspread about, what would that be? Maybe like a minute apart from each other, 45 seconds apart from each other, and it's almost exactly every 45 seconds, that's when the next connection took place. Yeah, that is a beacon. So this gives us raw quantity, and the higher the number, the more likely it is a beacon. But that doesn't mean that these aren't all normal, and this one way down the bottom with only 1,900, that isn't our beacon. So we're going to do a further analysis to figure out what's a beacon, what's not. But that's going to take us more time and more energy. We need to figure out, when is it worth doing that additional investigation? When is it not? So we have to kind of pick a threshold for that. But let's talk about that first one. So let's say we look at this first one and we say, okay, that might be a beacon. I want to do a little bit more analysis on it. What's that analysis? Well, notice what I've done here. So I'm still in the con log. I'm using brocut, source IP, destination IP, the original bytes. So this is how many bytes of data was sent by the internal IP address to that external IP address. And then I'm using grep to only look at what was my top number of communication sessions here. So I'm focusing in just on that one. And notice, so here we see I have 108,858 connections total. Well, out of that 108,858, 108,250, almost all of them, 61 bytes was sent from the internal system to that host out on the internet. Then I have 429 instances of when 262 bytes exactly were sent. So, and then it kind of goes down, and then we have a bunch of them where no data was sent. There was a connection attempt and nothing happened. And then, 13 instances where it was 122. So what does this mean? This to me looks like a beacon. Anytime you see this, an overwhelming majority of the traffic has the exact same session size, that to me says heartbeat. That is the, hey, do you have anything for me to do? No, go back to sleep. So what does that make the rest of these? The rest of these might be activation. These might be instances where the attacker said, yes, I have something for you to do. This is what I want you to do. All of the data sizes we see are small. That's good news, because that means if it was activated, at worst, they saw some running processes, a directory listing or something like that. Again, there's not enough data getting transferred here for this to be, they grabbed our entire customer database. So I've looked at this, I've said, hey, most of the traffic has the same size. This looks like a beacon to me. So now this is, is this a beacon, yes or no? I would look at this and say, absolutely. This is something I got to invest further. Now that I've run this against these two IPs, next I'd have to go to this IP on the list, do this exact same test. Then I would go in the next on the list, do this exact same test, and so on down. That's why I said you need a cutoff. At some point, I want to say, okay, there's a small enough number of sessions that I just don't want to bother. It doesn't mean it's not a beacon, and it doesn't mean you might not miss it. It just means that this takes a lot of work to go through and kind of do manually, and you need to stop somewhere. So the first, so this was go in and look at a session size analysis, and we can eyeball this. Meaning that, I talked about you can look at these things statistically to figure out, via k-means, is it actually a beacon or not, yes or no? I don't need k-means. I don't need any statistical analysis to tell me this is a beacon, because again, I have 108,858 sessions total, and almost every single one of them had the same size. This is a beacon. This is something worth investigating. But if I wanted to do the math, I could pump it through data mesh. So here I'm using data mesh to go in and look at the minimum value, the total count, the minimum value, the means, the mode, and the maximum value that was generated. So if I go in and I look at that, remember I was talking earlier where my minimum is usually the heartbeat. That's usually that. Do you have anything for me to do? No, go back to sleep. 99% of the time, that's going to be your smallest session size. And we identified our, let's see, our min is where it is in the data. Oh, it comes out as 1. Gee, that's helpful. But our mean here is 61, which is right around what we said is that most number of sessions that took place. So even statistically, this looks like a beacon as well. So we did a statistical analysis here. That's indicating it's a beacon, but we didn't really need it. We could just look at it from a data perspective too. Okay, so we've looked at long connections, we've looked at beacons, we said DNS is a popular C2 communication channel. So let's go check for DNS. So what I want you to do is you're still in that same lab1 directory. You've got a PCAP file and you've got some Zeek logs. I want you to go through and check to see, is there any indications that maybe we have C2 over DNS taking place here? In other words, if I find a domain that has more than 1,000 fully qualified domain names associated with it, that's a pretty good indication that it's being used for C2. So I want you to go in and look for that. Now you have a PCAP and you have Zeek log files. I'm going to give you a pre-hint and tell you that you can use either one of those. You can get this answer using the PCAP or using Zeek files, but I will say using Zeek files is faster. And I'll show and explain why in just a couple of minutes. So let me give you a couple of minutes to walk through this one.
Hey, Chris.
Hey, what's up, Jason?
Hey, I got a question for you.
Go for it, man.
How long will this session last now that we've had some adjustments?
How much time do we have left in this? We're down to the wire. We're probably down to like the last 25 minutes or so.
Sounds good. And then someone asked, any special configurations to Zeek if we wanted to recreate the labs with our own data?
Oh, good question. So the only thing special you need to do with Zeek is to match what we have here exactly is to install that JA3 plugin that I was talking about. So Zeek does not hash SSL TLS sessions by default. The JA3 plugin does. So if you install that, that'll match everything here. But everything beyond that, nope, Zeek will do it right out of the box.
Yeah. And then one other question, while we're waiting. Any advice for finding extremely long period beacons, like the once per day or once per week beacon?
So we're talking. So that to me is you're not trying to catch nation state because nation state isn't even that slow. You're trying to catch a red teamer that you're paying to see if they can break into your network and create a C2. They're not actually trying, they don't care about having it be useful. They simply care about being able to show they could actually make it happen. The only way to catch something like that is to have a large enough data set to be able to find a pattern in it. So if you're worried about something that beacons once per day, yeah, now you're probably looking at, you need a month's worth of data to catch it. If you're worried about it beaconing once per week, you probably need a year's worth of data and have this thing running consistently for a year before you can catch it. It kind of comes down to like, those are really your only options. So is it possible? Yeah, but not from a practical standpoint, but it's not likely you're going to run into it out in the field.
Should this first command be taking a few minutes to run?
Yeah, so the question was, should they? Yes, absolutely. So I mentioned Zeek runs a whole lot faster than T-Shark. So let me pull up these two commands here. So the DNS log file is pretty small, and it's only DNS records. So the second command actually runs pretty quickly. And all we're doing is we're going in and we're looking at what fully qualified domain names were queried, and we're pulling those out, and then we're just adding up how many of them that there are. We're doing the same thing here with T-Shark, but we're doing it in a PCAP file, and we got to look at every single packet that goes by. So yeah, I would expect the T-Shark command to take a whole lot longer than that second command. So if you're running the first one and it's not getting you anywhere, feel free to Control-C and just run the second one. And you can go back and try that one later, but honestly, the data output is the same. Now, playing with the data the same way both ways, but let me kind of talk you through it. And again, I covered this earlier. there's slides that kind of breaks out each of these sections of commands here, but let me kind of talk you through it again, just so you're kind of clear. So we're catting out all of the DNS log files. So we're just, outputting the display from all of those. And then we're piping that output through Brocut. And we're telling Brocut the only thing I'm interested in is the query field. What fully qualified domain name was the person trying to look up? Then I'm sorting them. So, all instances of www.google.com are all one line after another, all collected together, nice and together. And then I'm running it through the unique command. What I'm doing is I'm saying, okay, if I have 15 instances of somebody going to www.google.com, I don't care. Only save me one of them. And the reason for that is we're not looking at how many times did somebody connect to a domain or a fully qualified domain name. We're worried about how many of them are there within that remote domain. So all we care about is, what's there, not how many times each one was individually hit. Then I'm running it through the reverse command. What the reverse command does is it reverses all the characters on the line. So I might have a fully qualified domain name that is www.evil.com. And I want to see how many hosts show up in evil.com. Well, the fully qualified domain name might be www.evil.com. It might be www.eastcoast.evil.com. It might be it.eastcoast.com. In other words, there might be one or more subdomains after it, and I want to make sure I can accommodate for that. So by reversing the line, the first thing that shows up in the line is the word com backwards. The next thing that shows after that is actually the domain. So by reversing it, so by going in and reversing it and then sorting it and then going in and counting up how many instances I have of that, actually, no, I'm sorry, I'm back here. So by reversing it and then cutting out those first two fields, I'm getting, evil.com backwards. I'm getting Microsoft.com written backwards. I'm getting, Amazon.com written backwards. And then I'm just flipping it back again. So I'm flipping it back again so it's actually readable. Now I'm sorting it. Now I'm counting it. So again, this will show me how many hosts show up there. So here's what the output will look like. And it's actually pretty much the same for both of these. So I'm going through and, this output is the same as what we talked about before. So here is the top number of fully qualified domain names that showed up within r-1x.com. We get about 62,000. Akamai Edge had less. Edge, Amazon AWS had fewer than that. So we talked about that magic threshold being at about 1,000. If I see 1,000 or more fully qualified domain names associated with a remote domain, that's something that's worth paying attention to. So this is if I'm worried about DNS being used as a covert communication channel on my network, if I'm worried about people trying to tunnel traffic through it, this is a really quick, easy command to go in and kind of do a sanity check on that. Take all my Zeek log files, look for the queries, sort them, reorganize them, count them up, bang, here you go. Okay, last lab. So with this lab, we're going to look at all the same data, but we're going to do it using RITA. So the database is named Lab 1. And I've already preloaded that database into RITA, just to make life a little bit easier for you. So we've looked for long connections, we've looked for beacons, we've looked for command and control within DNS. We want to look for all three of those things all over again, but is it easier to do with RITA? So if you type in the word RITA at the command line, you'll get a list of commands. Now, I've got some hints here, but quite honestly, I'm going to make this one a little bit simpler just because of time. We're running short. And I'm just going to give you the commands. And I'm going to leave these up here for folks to kind of play with a little bit, and then I'll go through and talk you through. So figure another 5 minutes, and we'll go through and we'll cover this one too.
You got time for a question?
I sure do. Go for it, dude.
So Janine, I think it's Janine, said, I'm a sysadmin, so I have limited access and knowledge of all things networking. Would I ask my NOC to set up a set me up with a spanning tree if I wanted to capture a packet dump of all the network traffic, or just on my VLAN? I'm not sure what the terminology is. Still learning.
Yep, no, that's totally cool. So the first thing I would do is try it at home. And the reason for that is that gets you versed in kind of doing this. So one of my first jobs in this field was a sysadmin for NetWare. And the way I got that job was I went out and bought a 5-user version of NetWare, set it up at home, beat the bejesus out of it, and learned and cut the curve on it quickly, so that when the environment I was working with finally got their version of NetWare and got their hardware, I knew exactly how to plug everything in. I sounded like I had been doing it for years, and it was only because I had a home lab to play with. So my first recommendation would be try it out at home first. See what so that the Pi sensor that Bill talked about, I talked about the packet squirrel, give that stuff a try, and then figure out what looks interesting and how do you find it on your home network. Now when you go back to your NOC, if they're the ones that are responsible for being able to turn on a copy port, you can sound a lot more authoritative when you say, hey, I need to be able to identify this type of traffic in order to be able to identify command and control. And here's what I want to do, and here's exactly how I want to do it. And now you've learned it in this class, and you've set it up at home. You know how to make it all work, so that if somebody there says, show me, or somebody says, well, give me some more details, you're well-versed and ready to go.
And just to let everyone know, we are going to take this recording as well and make it available along with the other recording. So you're not going to miss out on that. And we'll figure out what to do with the certificates, with the registrations over there and the registrations over here. We'll do the best.
Yeah, we'll get it sorted.
Yep. And thank you all for joining us. I mean, you had a chance to jump off and you didn't. You're like, yes.
Yeah, that does say a lot. It was worth working it to come back in again. So
I also, one of the things about this is just based on the questions. It seems like, Chris, you and I were talking about a level 1 and a level 2. There might be an appetite for a level 2.
Yeah, which actually we're going to be doing at Wild West Hackin' Fest. So that's going to be 2 days of this based on Security Onion. So the tack's going to be a little different. This class has kind of been, if you don't know threat hunting, here's what it is, and here's the process, and here's kind of work with it. The class I'm doing at Wild West Hacking Fest is, I'm going to assume you already know most of that. I'm going to do a quick summary only. And most of the class is going to be, okay, let's take Security Onion and stand that up as a tool you can use to start threat hunting in your own environment. And we're forming the class in a way that you'll come in, you'll do a bunch of labs. And what I actually, kind of along the lines of what I was just talking about for that person that was asking about how to do it in their own environment, we're going to simulate that. So 2 days of, hey, here's how to do it, here's a bunch of PCAPs, here's how to process it. So now you can go back and you can immediately stand up Security Onion and start doing the same thing in your own environment.
We have another question from Muhammad. He said, is there a place where I can pull down packet captures of command and control so that he can practice? And just so you all know, our blog is at Active Countermeasures is the best place to go for that. And I think Keith is still on, but Keith is currently going through a malware of the day where he's pulling down a number of different instances of malware, and he's capturing the traffic for 24 hours. It's really just one system, but we want to make it so people can readily download it, and that'll be made available in the next few coming weeks. So yes, that is absolutely coming as well.
Yep.
Which class is going to be crazier, mine or yours? Mine is like just making attackers' lives hell. And I guess, the Security Onion one is like finding them when they're floundering around. So
yes, exactly. Yeah. So kind of combine that together. So we tag them, you bag them, right?
Yeah, exactly. How many packets have to traverse the Zeek tap sensor before it can detect the dynamic application in flight? I think it depends a lot on how many beacons, but usually we would say at least at a minimum an hour. If you're looking at something that beacons like once every minute, what do you think, Chris, on that? What would be the minimum you'd want to see?
That's funny. So I interpreted that question as being a little different. I interpreted that as how many packets does Zeek have to see before it could actually identify which application is using it. And the answer to that is it depends on the application. SSH it identifies because it sees the server identify itself, and then it sees the client initiate a secure session, and that's it. So it only needs, 3-packet handshake goes by. I'd say within the first 10 packets in the session, it's figured out is it SSH or not. But getting into something like identifying HTTPS, it's going to take more packets than that. So as far as the application identification goes, again, it comes down to the app, but Zeek does it very quickly. Now, with that said, to John's point about how much data do I need to see before I can identify it, it really depends on the beacon, as John was saying. If somebody's beaconing once per hour and I've got an hour's worth of data, I ain't going to see that. So I really, really strongly recommend, work with 24-hour data chunks. Because if you're working with like an hour, there's going to be stuff you missed. Now, with that said, an hour is better than nothing. But just keep in mind that if I'm using an hour, I'm only going to catch stuff where my beacon interval is less than a minute.
Yeah, absolutely. So, and I had one person that reached out to me. He said, so those really long T-Shark commands that take forever to run, you're telling me that you can do all of that with this handful of RITA commands?
Yeah.
Yes.
So yes. So let me give you a little bit of background on RITA. So what RITA is doing is RITA is pulling in this data, and then RITA goes off and kind of runs and processes the data. So you tell RITA, hey, go in and import in all of that Zeek data. And that import process does take a little while. But once it's imported, the data is just all there for you. Let's actually go through and kind of talk about some of these. So the first command, show database, didn't show output for that, but that'll just show you what databases have actually been loaded. I wanted to include that so that if you forget that the name of the database was Lab 1, it's really easy to load that back up and go to it. So the first one was, show long connections. And you can see all of that adding and everything else we were trying to do, RITA's taking care of all that for us. This is all here. Now, the one thing RITA doesn't do yet is cumulative of the connections. You have to kind of do that manually, but that there's actually a pull request in to add that functionality to RITA as well. So it'll do that also. But what's also I kind of like about it is, so before we had source IP, destination IP, and the total amount of time of the communication. But notice I'm also seeing things like, did we recognize the application layer? Now, this could be one of two things. So RITA needs to see the application in negotiation in order to figure this out. And most of the time, that needs to be the packets that get exchanged right after the TCP 3-packet handshake. So let's pretend that this top session started 5 days ago. So the SSL client hello and the SSL server hello and the digital certificate exchange that took place was 5 years into the past. It's not in the data set that I'm in. That's why it doesn't recognize this as SSL. That's one possibility. The other possibility is that somebody's tunneling over this port. So when I look at long connections and I see the application hasn't been identified, I always like to look at the timing. And if that's pretty close to the length of the capture, I probably missed that at the beginning of the session.
Hey, Chris.
Yes.
We're getting similar questions. How do you load the data into RITA?
There's a RITA import command you can go through and use, which I'm forgetting off of the top of my head, but it is in the documentation. And you can actually automate the process as well. So you can go through and just have a cron job run each night to import your Zeek data from the day before, so it's all ready to go when you show up first thing in the morning at 2 p.m. or whatever the case may happen to be. So it's fairly straightforward to go through and do that import.
So, Chris, we have a lot of people asking the April class, is it the exact same class as this? And I think the answer is no. Just by virtue of all the things that we are changing, there's going to be a tremendous amount of overlap, because I will be using these slides, but then we're also going to be probably adding in some Silky into that as well. So
actually, I think Silky needs to be its own class.
Probably be its own session.
Yeah, I think we've learned that GoToWebinar, we kill it if we try and do this many people. We're going to get this many people again. If we try to use GoToWebinar, we'll kill it. We can't run Webinar Jam for 6 hours. It needs to be a shorter class. So the biggest change I think we need to make in April is maybe we need to do it as 2 sessions as opposed to just 1, or we need to streamline the materials so that we're done within a 6-hour period of time.
Yeah, exactly. But yeah, but understand there's hardly anybody that's doing anything like this. I mean,
Yeah.
I don't know if you all noticed, but when you were joining GoToWebinar today, GoToWebinar's authentication came to a crawl. It took me like 30 seconds to get logged in as a moderator. And that's because we had literally 1,000 people hitting it at the exact same time. So yeah, I was glad it went as well as it did. That was great, but that's why we have backups to backups. So
yeah, exactly. Yeah, all right. So let me bring this home, and we can all call this a day. So the RITA show long connections, that just shows me all the long connections that took place. I don't have to run any hoops with T-Shark or anything else, which makes life a whole lot easier. If I need cumulative talk today, I can run it through data mesh. Same way I talked about before. So I could go in and add things up this way, and that's fine. I will say RITA will do this by default with another command switch, probably within the next month to 6 weeks or so. So that will give you the ability to look at cumulative communication time as well. Beacons, quite honestly, this was the thing that sold me on RITA when John first showed this to me, because it just boom, and it does it. This is a really simple way. We talked about look at connection quantity, and you need to look at timing. The software does all that for you. So the important thing is this number in the left-hand column. This is the percentage that we're certain it's a beacon on a scale of 0 to 1. Why 0 to 1? I don't know. I didn't write the software. Somebody thought that was a good idea, and it works.
Math,
yes, because math. But these first 2 entries, we're saying, 1, we are 100% positive this is a beacon. We're printing out, here's the number of packets that we saw. There's a lot of statistical information that gets fed back as part of this as well, which I found we've done a poor job of documenting for everybody, but I've got a couple of our engineers working on doing blog entries to kind of explain, what does the rest of this stuff mean? To go through to be able to kind of decode that. If you want to kind of check our math, so to speak, and go through and do that. So what do I need to look at here? Well, these are perfect beacons. These are absolutely worth taking a look at. My next one after that, we're saying we're about 84% certain this is a beacon. Well, once you get down into the 80s and below, it's probably not worth a whole lot of your time. So those, for me, I wouldn't bother. I'd pick on the first 2, and that's it.
And Chris, the other thing is, if you look at the connection count on these, the connection count, as soon as you get past the beacons, drop down to like 200 connections to 69 connections. That's another dead giveaway. You would want to get to them if you're working in an environment like when we're doing threat hunts for compromised environments. We definitely get down into those, but
yes,
you want to focus on the high talkers first.
Yep, agreed. And John and I talked about, just because it's a high talker doesn't necessarily mean it's a beacon. How do you kind of tell the difference? We've already done that for you. So that's already there. If it's got a score of 1, it's a beacon. It doesn't matter if it has 10,000 packets or 1,000 or 1,000,000 or whatever. If the score says 1, yeah, that's a beacon. That's worth digging into a little bit deeper.
We did have someone say, is it possible for RITA to output the format in a more readable format? It does in 2 things. You can do the -H for human readable output, and you can also run an HTML report that'll put this into a table inside of an HTML web page.
Yeah, and actually, that's something I missed in this deck. You can actually run a command line web browser and load it up in that, and all of this just is a whole lot cleaner and easier to navigate if you want to go through and do it that way. So that's another change we'll have to add in. C2 over DNS, I can go in and I can say RITA show exploded DNS, and it gives me kind of 2 sections of information. The first is it gives me these nice summaries. So again, more than 1,000 fully qualified domain names, that's something I need to pay attention to. These stick out like a sore thumb, so that shows up at the very beginning. And then as I dig through, I can see, this is my C2 channel. So this is part of my command and control. This is part of my calling home to say, do you have anything for me to do? What answer comes back to that question is my command and control orders. Now, you may look at this and say, Chris, I could write a signature for that. I could just go in my IDS and say, hey, anytime you see a host name that is 202020, flag that and alert on it. And could I do that? Yes. Will I catch DNS Cat 2? Absolutely. Will I catch all DNS tunneling that's taking place? No.
Well, and that gets into the problem of static signatures, right? And if an attacker is wise, they can just change the code of DNS Cat to bypass that again.
Absolutely. Absolutely. So again, this goes back to the very beginning of this class, which, oh my God, that seems so long ago at this point with all that's going on. But I showed you Saricata, and I showed you Saricata can't catch DNS Cat 2 out of the box. Well, you could easily write a signature to catch it, and that's great for DNS Cat 2, but you still got to do this to make sure that you can catch any variations that come out later. So next steps. In other words, we've gone through this data, so now we need to ask ourselves what's worth looking at. In other words, we've looked at, a bunch of different IP addresses, a bunch of different ways. What does it all mean? What's worth taking a look at next? So let me just kind of back up a little bit here, and let's just work with the RITA data, because that kind of makes sense. So from a long connection standpoint, I've got a couple of systems here that are carrying on long connections with systems out on the internet that make me a little bit nervous. So those are systems that are going to want to go in and do a little bit more of a deep dive on. I have two systems that are running perfect beacon scores. So this is something that I want to dig into a little bit deeper. So now I got to look at so what does deeper mean? What do I do next? Well, for these two beacons, and I think there was like three, maybe four long connections. Next, I go in and look at who are they talking to? Are they on a threat intel list? Where are those systems located? Are they a business partner? Are they a field office? Do I recognize where the traffic's going? This is where I start, so this is my primary modifier for my threat score. Now I start jumping into my secondaries to try and whittle it down from there. Once I've gone through my secondaries, now I've got to ask myself, okay, what do I do? For each one of these internal IPs, my next step is, again, is threat hunters, this is our primary job, is going through and dispositioning each of these IPs. Is it safe? If so, anything I saw that looked weird, whitelist it. Is it evil? If so, go into incident handling mode on that system. If I'm not sure, I need to collect up information because I have to be sure, those first two values, I need to be able to get to that for everything, for every IP. I need to be able to say safe or not safe for everything. That third answer is kind of a cop-out. It's the I don't know yet. Well, you need to know. That's your job. So what data do I need to collect and how? And that's going to be kind of driven on what I've seen so far and what's available. So it might be pull off system logs. It might be, do full P captures. Again, it kind of depends on what resources I have available. Now, this is not an ad, but it kind of is. But now that you've kind of gone through and you've looked at what does it take to do it manually, what does it take to do this using RITA, we do offer a commercial tool to kind of deal with this. And it is cheap. It's a site license, which means you can run as many instances as you need to for the same price. And it's less than 10 grand, so it's very cheap compared to what's out there. But things like we kind of talked about creating a threat score, our tool does that for you. So it goes out and it looks at a bunch of different criteria that could indicate that this is command and control, works that into a score for you, so you have a nice action item list to start at the top and kind of work your way down from there. We have some great screens to easily go through and navigate, what's a long connection, both from a individual connection standpoint, from a cumulative connection standpoint. Beacon analysis, we have screens for that to go through. So wait a minute, Chris, I don't understand everything that's here. You don't necessarily have to start. One of our goals with this was, so I've run a couple of security operations centers, and typically the demographics of that are, I have one guru, I have like one Bill Stearns that really knows what they're doing, and that's it. And that person is booked 50 hours every 40-hour week. Meaning that if someone comes to me and says, hey, I just created this security widget that's awesome, and does these great things, but it's very highly technical to use it. And the only person who could use it is your highest guy, Bill. I'm going to tell him to go away and leave me alone because Bill's already too busy. So any tools that only the high-end folks can work with doesn't do me any good. I need tools that low-end people like interns can actually figure out what to do next to use. That's really what we focused on here. So to look at a score and to see, hey, the score has gone up. Yeah, an intern can do that. To go in and look at, oh, it's flagging it as a beacon, and oh, hey, look, I can draw a flat line here. Yeah, that's a beacon. That's something an intern can do. So the idea is we wanted a tool that junior analysts could be your first line of defense doing this threat hunt, and then they can pass it off to a senior person when something really has been found. So the beacon screen, we also give the ability to go in and kind of drill down on things. So if I'm looking at this IP and I say, I want more information about this external IP address, we've got references to a bunch of different resources out on the internet that will tell you more about that. And if there's something you want to use that isn't here, you can add in your own. So for example, like the internal IP address, one of the things I can do is I can say, hey, I run Carbon Black Response. I want to add Carbon Black Response to this menu so that when I'm looking at something suspicious and I want to see what was going on with that internal machine, click, click, bang, I'm now in Carbon Black Response and I can do my investigation from there. One of these, the deep dive, this is one we actually do ourselves, and I'll show you that one in just a second. The DNS screens we were looking at to kind of figure out what's going on, that's all out of this tool. And again, it kind of scores everything, it takes care of it for you. This is that deep dive analysis. So all of the modules in the tool are kind of based around attack vectors. So we're looking for long connections, beacons, that type of thing. This one module is a little different. It's kind of one-stop shopping to see everything. So I can go in and I can say, okay, hey, look up IP address 192.168.88.2 and tell me everything you know about it. Well, now I get to see a summary of all the communication it did with the internet the day before. I can click on any of these IP addresses and see a summary of the communications it had for that with that. One of the other things this is really cool for is, remember I said you want to be able to pivot easily. So I find an internal system that's beaconing to an IP address out on the internet, and I'm pretty certain it's compromised. The next thing I want to be able to figure out is, okay, who else on my internal network has been talking to that IP address, because they're probably compromised too. You can easily do that with this tool. I can go in and I can say, hey, show me that external IP, and now I'll see all the internal IP addresses that were carrying on a communication with it. And I want to just kind of leave that at that, meaning that I don't want to go through and turn this into an ad, because that wasn't our intent here. But I do feel like we've created a tool that simplifies this process, and I kind of felt like it was cool to kind of add that one in. So with that said, we are done. Thank you for attending. I really appreciate what everybody went through today, especially since we had to kind of jump ship and go on to a different platform to keep this going. I'm going to have to get that other problem sorted. We had intended to do a poll on feedback at the end here, and that just crashed and burned. It didn't happen. So if folks are cool with it, we'll probably send it out. I've made sure it's limited to 5 questions. Actually, it's limited to 4. So it's just 4 questions about, hey, so we did this all at once. Should we have done it as multiple classes? Which did you prefer? What do you think of the platform? Number 5 is just, hey, if you got any additional feedback, go through it. It would really help us a lot make this better if you could fill that out, so that would be cool. And at the end of the day, any feedback you have at all, please feel free to just send it to me, Chris@activecountermeasures.com.